Welcome back to the MOOC course on strategy and introduction to game theory. In one of the earlier modules, we talked about auction. We introduced the notion of auction and we talked about different types of auction. In this module, we are going to talk about auction as a game. The idea is to model auction as a normal form game. So far you have studied a normal form or a strategic form game. What we have learned that to describe a normal form game, we need to give three pieces of information. First, we need to give the list of players. Okay, that is the first information required. The second piece of information is that we need to give strategy set for all the players. And third, we need to give utility or payoff associated with all different strategy profile. Okay. So, let us look at this auction, a very simple auction we will talk about. So, who can be the players? N potential bidders. Since we are looking at auction for the first time, what we will assume that it is one sided auction and only buyers are interested, buyers bid, seller is not bidding, only one sided. So, we have n potential buyers as players. Then we also have to think about what would be the strategy set of a particular bidder. So, how much money a bidder can bid, how much money a bidder can bid? He can bid any number from 0 to, let us say, infinity. So, that is what I am saying, that strategy set of a bidder I is a bid that comes from a set of all non-negative numbers. And what would be the payoff? Of course, the payoff would depend on the strategy profile, but one thing is very clear, that if he loses, then he earns 0. Let us ignore monetary value of time, the time that he would devote to participate in the process. So, that we will ignore. So, if he loses, he does not pay anything, he does not get anything. So, we will say he gets 0. And if he wins, then depending on the type of auction, he will have to pay certain amount. So, his payoff would be the amount, the value that he associate with the good minus the amount he pays. So, we are able to describe all the three pieces of information. So, auction can be modeled as a game. Of course, I am not very right now, I did not describe the exact payoff. The exact payoff will depend on the type of auction, type of valuation, okay, and also here how does winner get decided. And very clearly at this level, seller is not a player in the game. To describe auction as a normal form game, we need three pieces of information that I described: players, strategy set of bidder I, and payoffs. Of course, I said the winner wins, the winner gets the object and he pays certain amount, but of course, the rule of the auction would determine the game also, that how does the winner get determined. Of course, all the bidders valuation would play a role, and type of auction is also very important to decide how much would be the payoff. As in the first price sale bid auction, a winner has to pay amount equal to his own bid, but in the second price sale bid auction, he pays the amount equal to the highest from all remaining bids. Now, the next question is the seller a player in the game? Typically, the seller decide the format for the auction. He does not participate in the auction actively. So, if we are thinking about which auction format does the seller choose, then of course, we should consider seller as one of the players. But once the seller decides, at best he is passive player in the game. So, we would not include seller in the list of active players or the players in the game. So, let us think about Vickrey auction. And what is Vickrey auction? Second price sale bid auction, and we will also assume the players have private valuation. Of course, as we discussed earlier, players would be all the bidders, strategy set of bidder I would be a set of all non-negative numbers. What would be the payoff? If he submits the highest bid, then amount equal to her valuation minus the highest among all remaining bids, and 0 if he does not submit the highest bid. Can we calculate, can we figure out the Nash equilibrium of the game? By now I hope you understand the importance of Nash equilibrium in game theory. So, how can we figure out the Nash equilibrium of this game? The technique that you have been using mostly is of drawing tables. That would be difficult to use here, as we have infinite different bids coming from finite number of players. Okay? Let us say even between 0 to 1 we have infinite real numbers, the different numbers a player can bid. So, one way to do it is to restrict ourselves to whole number and say and make a smaller table, that would work. But if we want to do it little rigorously, then we should allow that bidders can bid any non-negative number. So, to figure out Nash, before we figure out the Nash equilibrium, let us look at some other techniques that you have learned, like dominant strategy equilibrium. Do we have any dominant strategy equilibrium in this game? How can we figure out? If all the players have either strictly dominant strategy or weakly dominant strategy, then we can say we have dominant strategy equilibrium in the game. So, let us pay attention to bidding strategy, optimal bidding strategy in this sort of auction. We will classify, of course, we will classify a bidder strategies in 3 different groups. One, that a bidder bids truthfully, means if its valuation is, let us say Vi, he bids Vi. Second category would be, the second set would be, although I am writing here just strategy 2, but basically it is a set. Bidding truthfully will have only one element, the bid equal to his true value. But when we are talking about second type of a strategy, bidding more than the valuation, then of course we are talking about a set of strategies characterized by where all the bids are higher than his true value. So, like if he values the object 5, he is bidding something more than 5. And third category is bidding less than the valuation. So, again going with the same example, if his valuation is 5, he is bidding something less than 5. Let us see what happens if he bids truthfully. Here is a case, in yellow color it is his bid, and in orange color we have other player's bid. Since player I is bidding truthfully, he wins only if his bid is highest, or otherwise he loses. If his bid is highest, it means his valuation is also highest, because let us say that we not only for player I, we are doing it for all the players. So, everyone is bidding truthfully, okay? Then what happens? That player I wins only if his valuation is the highest, otherwise he loses. Next we are taking the second category, in which a player I is bidding more than his true value. What happens? Here is player I's valuation and he is bidding this much, this is increasing in valuation. So, he bids this much more. In this scenario there can be 3 different scenarios. In one scenario, that his bid is not the highest. Okay? So, in this case what happens? He does not win, as his bid, he is not submitting the highest bid. Even if he had bid truthfully, he would have lost. So, in this case it does not matter whether he bids truthfully or he bids higher than his actual valuation. Let us look at the scenario 2, in which his bid is the highest, okay, and his valuation is also higher than all other bids. What happens in this case? he bids this much amount, second highest bid is this much. So, how much he pays? He pays second highest. Remember, it is Vickrey auction. He does not have to pay amount equal to his own bid, he has to pay amount equal to the highest among all remaining bid. Let us say what would have happened if he had bid truthfully. In this case, this would have been his bid and still he would have won the auction, because this would have been the highest bid. So, we are talking about moving this to this, and how much he had to pay? Same as this label. So, in both the cases his payoff would have been this much positive amount. Okay? So, whether he is bidding more than the true value or he is bidding truthfully, in scenario 2 it would not have made any difference. But let us look at scenario 3. Here also his bid is the highest among all other bid, but someone else is bidding a value higher than the true value of player I. What happens? In this case, player I wins as he is submitting the highest bid. How much he has to pay? The highest bid among all remaining bid. So, this much he has to pay. How much value he gains from this winning this auction? This much. So, basically he is losing this much. If he had bid truthfully, then what would have happened? He would have bid this much rather than this amount, and someone else would have won the auction because someone else had submitted this higher bid. So, in this case his payoff would have been 0. So, 0 versus some negative amount. Of course, 0 is preferable to some negative amount. So, in scenario 3, if he had bid truthfully, he would have done better. So, what do we see when we compare strategy 1 and strategy second type of a strategy? What happens? That bidding truthfully is always at least as good as bidding more than the valuation, and in some of the cases bidding truthfully is strictly better than bidding more than the valuation. What does it mean? That bidding truthfully weakly dominates any strategy in which player bids more than his true value. Okay? Now, let us move to the third type of bidding strategy, in which a player bids less than the true value. Again we have 3 scenarios. In the scenario 1, his bid is not the highest, but in this case also we are taking that his valuation is also lower than the highest bid. In this scenario, bidding less than the true value or bidding equal to true value, both would have given the same outcome to player I. Okay? For example, his payoff is 0. Even if he had bid truthfully, his payoff would have remained equal to 0. Now, let us look at scenario 2, in which player I's valuation is higher than all other bids, but he is bidding less than his true value. So, he is bidding less than his true value. What would happen? Because he is bidding less than his true value, but is still greater than all other bids. So, he would win. And how much he will have to pay? He will have to pay this amount. So, his payoff would be equal to this much positive, because he has to pay this amount and he is gaining this much by winning the auction. So, he is gaining this much of positive amount. If he had bid truthfully, it means he would have bid this much. Again he would have to pay the second highest amount, that remains same as this. Again his payoff would have been the same. So, bidding truthfully or bidding less than the true value is same as bidding truthfully in scenario 2. Let us look at scenario 3, in which player I's valuation is more than all other bids, but he is bidding less than his true value, and in this particular case what happens? He bids less than someone else. So, in this case he loses, because here is the highest bid and it does not belong to player I, and he gets 0. If he had bid truthfully, then he had to pay amount equal to this bid, because then this would become second highest and his gain would have been a positive amount. So, bidding less than the true value does as well as bidding truthfully in scenario 1 and scenario 2, but does worse than bidding truthfully in scenario number 3. So, what do we see again? Bidding truthfully is as good as bidding less than the true value in all the cases, but in some cases bidding less than the true value, bidding truthfully is as good as bidding less than the true value in all the scenarios, but in some scenario bidding truthfully gives strictly better results than bidding less than the true value. So, what do we see? That bidding truthfully again weakly dominates any strategy in which player I bids less than his true value. So, if we take all three together, what do we see? Bidding truthfully is weakly dominant strategy for player I. So, what do we see? There is nothing special about player I. The argument that we just discussed would be true for all the players. So, for all the players bidding truthfully is weakly dominant strategy. So, what do we get? We get a strategy profile in which all the players bid truthfully, and this strategy profile would constitute weakly dominant strategy equilibrium. And we know that weakly dominant strategy equilibrium is a Nash equilibrium. So, we obtain a Nash equilibrium for this game. Now, can we talk about any other Nash equilibrium in this game? As we have discussed, we have figured out one Nash equilibrium for this game, but the fact is that in this game we can have many more other Nash equilibrium. For example, let us take for simplicity only two players, and let us say that player 1 has valuation V1 and player 2 has a valuation of V2, where V1 is greater than V2. If player 1 bids V2 and player 2 bids V1, is this a Nash equilibrium? Let us see. When can we call this a Nash equilibrium? When by deviating, by unilaterally deviating, none of the player can make themselves better off. So, let us look at for player 1. Can player 1 make himself better off by deviating? So, instead of V2 he bids more than V2. If his bid is still less than V1, then he still loses and he gets 0, as in this case where he is bidding V2, because V1 is strictly greater than V2. So, player 2 wins. But if he bids more than V1, then what happens? He wins the auction, and then the new would be B1 and V1, where B1 is greater than V1. In this case he wins the auction and he has to pay amount equal to V1. So, his net payoff would be V1, as V1 is the valuation for this person, and minus V1 as this amount he has to pay. His payoff would be 0, same as the case when he loses the auction. So, player 1 does not have any incentive to bid, to change his bid. How about by bidding less than V2? If he bids less than V2, he definitely loses and he makes he will have a payoff of 0. So, he does not have any incentive to deviate. How about player 2? Player 2, if he bids more than V1, again he wins, he has to pay amount equal to V2, his payoff would be same as the earlier case. In both cases he would have 0. So, he does not have any incentive to bid more than V1. How about less than V1? If he bids a number between V1 and V2, he wins, still he will have to pay V2 and his payoff would be 0. But if he bids less than V2, he loses and his payoff would be 0. So, by deviating he is not able to increase his payoff. So, we can say he does not have any incentive to deviate, and V2 comma V1 would be another Nash equilibrium. My request to you would be to try to figure out all the Nash equilibrium in this simple game. This would be a very interesting exercise. By the way, so far we have been talking about sealed bid second price auction. What would happen in English auction? In English auction, is it possible that player 1 will bid V2, which is less than his valuation, and player 2 would bid V1? Probably not. We are going to come back and revisit this when we talk about extensive form game, that is a other form of game that we are supposed to discuss. How about first price sealed bid auction? Try to obtain Nash equilibrium in the first price sealed bid auction. But see, okay, so we have been talking about the sealed bid auction. Here of course, seller is conducting the auction as seller does not know the valuation of different players. But the thing is, all players know each other valuation, because we have assumed here the player 1 knows player 2's valuation, player 2 knows player 1's valuation. That is bit funny, that is not practical, but it is a good intellectual exercise to understand the basic auction format, what happens if bidders or buyers they know each other's valuation. Later on we are going to revisit the topic again, and we will discuss auctions where player is a particular bidder is aware of his own valuation, but he does not know the valuation of other players for sure. That would be much more interesting to study, but for that you will have to wait. Thank you very much.